Let's solve another situation of a quadratic equation using completing square. A situation where it's not that straightforward how to fold our trinomial into a square of a sum. The problem in this situation is the third term, positive 12, which supposedly is some number, an integer, to the second power, but we know that there is no such integer that to the second power would give us a 12. So we cannot be doing the same thing as in the previous example. So I suggest that we use an algebraic trick or a subtraction property of equation, and simply we'll get rid of this positive 12 since there is not much use of it. How do we do that? We subtract 12 from both sides. Remember, as long as we do to left the same as we do to right, the equation remains balanced. So you will receive an equivalent to it equation that will look a little shorter and will gain the negative 12 on the other side. For us to be able to solve or to fold the left side, we would have to have a trinomial. But here is a problem. Of course, we have only two terms here. And of course, we desperately would like to have something right here in the third position. That term in the middle is something that we could get if we add that number to both sides, left and right, to keep our equation balanced. Can we figure out which number it should be? I think we can. If we look at the middle term, the term that contains a variable to the first power, that is, of course, positive 10x. And if we try to figure out which number multiplied by positive 2 and the x would give us this term. Of course, that number should be 5. 2 times x times 5 will give you positive 10x. This means that b, the term that is missing here that we desperately would like to gain, would be b to the second power, or simply 25. So, if we were adding 25, then we would have to do it to both sides simultaneously, just to make sure that our equation is still balanced. This is what a property of addition for an equation allows us to do. In this case, our equation could be simplified where we will not touch anything on the left side. It will now become a trinomial, but the right side, now combining the like terms, will produce a positive 13. These three terms still have a plus between them, and they now will be folded into a square of a sum, because the third term, the one that does not contain any variable, the positive 25, actually could be rewritten as 5 to the second power and give us this 25. And of course, for the sum itself, I will use x as the first term. So the final result will look like this. Remember that the right side will have to be 13, and that would be the equation that we will solve further. Now, I'm going to pause here and stress the fact that if you are learning not to just solve these quadratic equations, but to solve them with the purpose of identifying later equations of a circle, then all of these steps are the steps that you need to master. If you were solving the equation, then of course you need to know these steps, and then you need to remember that to solve an equation with an exponent over your polynomial, you will have to get rid of this exponent. which calls for the opposite operation applied to both sides. The opposite operation is taking the square root, both negative and positive, from both sides, and then remembering that square of a number cancels the operation of taking the square root of that number, and of course that would produce simply a binomial x plus 5 on the left side for the positive result, and positive square root of 13 on the other side, or a second possibility where you will have x plus 5 binomial and negative square root of 13. Then you will solve these equations individually. In the first case, you'd subtract 5, and your answer will be approximately negative 1 and 4/10. Whereas in the second situation, you will follow the same steps, but the result would be different, approximately negative 8 and 6/10. You can even verify your solution with a graphing calculator. Dial the same original quadratic equation, graph it, so you see a parabola, which means that there are now also 2 points of intersection whose x-intercepts represent your solutions. Here as you see the minus 8 and 6/10, which you will verify by simply subtracting negative square root of 13 and 5. And the other root, the root on the right, produces your negative 1 and 4/10, which you also can verify with a calculator.